Okay, so for our last lesson of chapter 10, we're going to talk about writing the equations of circles. So even though we're done with triangles, we're not really. We're going to see a connection here. So for those of you that love triangles, yay! Here we go. All right, so let's talk about what we're familiar with. They're saying let x and y represent any point on the circle with a center at the origin and a radius r. Okay, so they've labeled a random point xy right there. Well, if we know that the radius is r, if we want to define the length of r, we want to know how long r is, then we can turn this into a right triangle, say x and y, because that's how we get to that point. And x squared plus y squared equals r squared. That's the Pythagorean theorem. There's our right triangle. So this is true for, this is the equation of a circle with a center at the origin. Now, we could have a circle here, or kind of splitting the axis. It doesn't have to have a center at the circle. So let's see how our equation is going to change for a more standard scenario for any case, okay? All right, so we saw briefly there how it originates from the Pythagorean theorem, why it is x squared plus y squared, that distance across the x-axis plus the distance up to get to that point is going to make a right triangle with the radius r squared. Now, standard equation of a circle. Like we said, our center doesn't have to be at the origin. So if I make this right triangle, okay, here's x. I'm going to carry this down. This is x. This is h. So this distance between here would be defined as x minus h, right? So this length can be defined as x minus h. Now I'm going to do the same thing with the y's. This carries over, this is y. This point here carries over, this is k. So this distance between here is y minus k, which is what we have written here. So if I just focus on my right triangle, I can say that using the Pythagorean theorem, x minus h squared plus the other leg, y minus k squared, is going to equal my hypotenuse, r squared. And there you have your standard equation of a circle. Okay, the center applies to anything. This works for the origin or any point on there where our x value is written as h and our k value is written as y. And again, they do that because we've already defined a point as xy right here. So they aren't going to do two xy's. That gets confusing and subnode numbers. So they just made it hk. And then our radius is r. Okay, so our goals today in this lesson is to practice writing some equations and working through what we're given. So write the standard equation of each circle. So part A is a circle at the left and part B is a circle with those characteristics. So part A, let's first identify what our center is. So my center in part A is actually the origin. That's going to be pretty nice. 0, 0. And my radius, I already know, is 1, 2, 3. And I can see that's the same all the way around. So I was accurate with my center. My radius is 3. So now all I have to do is I scrolled up so we can see this equation. I'm going to sub these in here. So it's going to be x minus 0 quantity squared plus y minus 0, because those are my h and k, and then that's going to squared equals my radius 3 squared. Okay, simplifying that, I get x squared plus y squared equals 9. And that's the equation of this circle. You've got it. Now, if you just a little tidbit, you might be thinking, if I knew my origin was 0, 0, do I have to go ahead through this step? And no, you don't. You can just jump right to the final answer. And don't forget to square your radius. Okay? All right, now the next one's not drawn for us, but they give us some info. So we have, in part B, we have a center at HK. Okay, and that center is, in this case, 0, negative 9. And we have a radius, it's a unique number, of 4.2. Okay, so I'm just going to set up my equation. Here it is again, just so we can keep it in mind. X minus h squared plus y minus k quantity squared equals r squared. Okay, so x minus h is x minus 0 squared, plus y minus k, y minus negative 9 squared, equals r squared, 4.2 squared. So now I'm going to simplify a little bit. I don't need to do any factoring or anything. All I know is that x minus 0 squared is really just x squared. But I'm going to rewrite this as y plus 9 and keep it squared. And that's going to equal 4.2 squared, which is 17.64. And this here is the equation of a circle. So kind of cool that you can write an equation of a circle. I know in Algebra 2, I used to have students make diagrams and graphs, or not diagrams and graphs, but like drawings of sorts is what I mean by diagrams and graphs. So they would write names or letters using different equations, and circles was a common cool one. You can make some eyeballs, smiley faces, stuff like that. Okay? All right, let's try the next one. We're just going to keep using this understanding of what equations are of circles and apply it. Okay, so some practice here at the top. All right, so the first one they tell us has an origin. The center is the origin, so that's good to know. It's going to make our problem easier. And then we have a radius of 2.5. Okay, so I'm going to say x minus h squared plus y minus k squared equals 2.5. Okay, now again, I'm just rewriting it there. I can sub the zeros in. Oops, 0. You don't have to do this part. Oh, I forgot to write squared. 2.5 squared. But in the end, the answer is x squared plus y squared equals 6.25. Okay? All right, there's our first equation. Now the next one doesn't have it centered at the origin, so again, just x minus h squared. I would recommend you write this a few times. That's why I'm writing it, just so that you get the familiarity with seeing it a lot. The more you see it, the better it goes. So this is going to be x minus negative 2 squared plus y minus 5 squared equals 7 squared, which in the end becomes x plus 2 quantity squared plus y minus 5 quantity squared equals 49. There's our equation. Okay. All right, now let's move on to the next parts. Now in these ones, they're asking us to write the standard equation of a circle. But they're not just telling us the center in the radius. We can figure it out, but they're giving us some other pieces of info, okay? So they give us the point on the circle, negative 5, 6, and they tell us the center is negative 1, 3. So I know my HK, if I write center is negative 1, 3, I know my H, my K. What I don't know is what my radius is. This is what I have to figure out. Now there's a couple ways of doing this. Could I turn this into a right triangle? Can I do that? Yes, I can. I can say my distance across the bottom is 4. My distance along the side is 3. So maybe you're thinking, oh, Pythagorean triple. R is going to be 5. And there you have your answer. So one way to find your radius is, in this case, we can use Pythagorean theorem. Okay, and I know my answer is that r equals 5. I'm going to write that down. One way is Pythagorean theorem. I also could have done the distance formula, which I'm not going to do here. But I could use the distance formula between the points negative 5, 6 and negative 1, 3. So distance formula, remember we take x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So this could be x1, y1, x2, y2, and you could do that as well, okay? And then the last way is actually going to use our formula. So I want to show you that formula for equation of a circle. Okay. Now I know we could, at this point, we could go ahead and figure out the equation of this particular circle. We're going to write that in just a moment, but I want to let you see how you could do it. If you didn't apply the Pythagorean theorem, maybe it wouldn't work out. It just didn't dawn on you or something like that. So I'm going to say x minus h squared plus y minus k squared equals r squared. When you have an equation, you can only have one unknown if you only have one equation you're working with. So in place of x, I'm going to use these as my x and y. So it's going to be negative 5 minus, this is my hk. Negative 5 minus negative 1 squared. My y is 6 minus 3 squared. And the only thing I don't know is r. Okay, so that becomes a plus. Negative 5 plus 1 is negative 4. Negative 4 squared is 16. 6 minus 3 is 3. 3 squared is 9. And you can see where this is going. I'm going to get 25 equals r squared. So r equals, that answer we already knew, r equals 5. So no matter how you try to do it, you're going to get the same answer. All right, but in the end, the only thing they really want in this problem is the equation of this circle. So your final answer would look like this. You would say x, stopped writing, sorry, x minus, again, my center, negative 1. So I'm going to write plus 1. That's really x minus negative 1, just so people know where that comes from, plus y minus 3 squared equals r squared, which is 25. So that was r squared, which is 5 squared, which is 25. And there is my equation of the circle that they've shown me on the right. Okay? All right, we're actually almost done with this lesson, so we're going to do the tiny bit that remains. This next example you cannot do. It involves completing the square. That's a concept you'll learn in Algebra 2. Some of you may already know it, but it's not a required part of the Algebra 1 curriculum, so we're not going to throw that in right now. It has a lot to do with factoring and that portion of the chapter. But let's turn the page. I'd like to do 2 more with you. Okay, so the first one here, number 3. Okay, so practicing again, I've already graphed it. It says the point 3,4 is on the circle with a center of 1.4. So we'll work through that together. So 3,4 over 3 up 4, that's on the circle. Our center point is 1,4. So actually I think it would look more like this. Okay. Now, we know our center point, HK. What we don't know is the radius, and we just said there's 3 ways of doing it. But look at this. The distance here I can easily calculate just by you looking at it. This is going to be 2 units. So this one works out nicely. So my radius equals 2. So my full equation for number 3 is just going to be x minus 1 squared plus y minus 4 squared equals r squared, which is 2 squared or 4. And that's how I get my answer. So again, that was the radius squared, 2 squared. So it's really not that bad at all. Again, if you didn't know that, you could have gone ahead, notice they have the same y's, but you could have used the distance formula here. You can't make a right triangle, but the distance formula would work as well. If you use those 2 points, you would still get an answer of 2. All right. If we move down, so again, that one was completing the square, and we're actually not going to do these either. We're not going to write a coordinate proof involving a circle, so you can skip those ones. There's just one that I'd like to look at to finish up here, and it tells us that using graphs of circles. So the epicenter of an earthquake is the point at the Earth's surface directly above the earthquake's origin. A seismic graph can be used to determine the distance to the epicenter of the earthquake, and they are needed in 3 different places to locate that epicenter. So the question is, why are seismic graphs needed to locate? Why are 3 of them needed to locate the Earth's epicenter? I see we're close to the end, so I'm going to pause this real quick, graph it, and then we'll talk about it, okay? All right, let's do that. All right, so I've gone ahead and I've color-coded each of these 3 readings from location A, location B, location C. I wrote the equations that go with them. That's not really necessary, but it's just a little practice. Again, x minus the first number squared plus y minus the second number squared equaled 7 squared. X minus 4 squared plus y minus 6 squared equaled 4 squared, which is 16, and x minus 3 squared plus y minus negative 2.5 is plus squared equals 25, 5 squared. Okay, now when I graph them, notice they all happen to coincide at this point 5, 2. So what that means is, why are 3 of them needed? Because that's the only place where 3 of them can coincide, and that helps them identify the center of the earthquake. All right, check your homework and I'll see you soon.